This conference will now be recorded.
You know what? Generally, what I do is I delete my AWS instances on a regular basis. So due to that reason, again, I have to install Docker. You people don't need to repeat these steps. So just give me a minute. We have already seen the process of how we can install Docker in our previous session. So I'll just quickly open get.docker.com and try to install it, but the page is not getting opened up. Just a second. What happened? When I say get.docker.com, it's actually downloading some software into my machine. Just an index.html file. The page is not responding. Wow. Fine, it's okay. Generally, the get.docker.com, the advantage is that they have given a script which is capable of doing the installation on generally all the flavors of Linux. But if that is, in our case, we are not able to open that page, right? Maybe that site is down or whatever. So in order to go with the actual installation, I'll just go to the Docker site and we'll try to execute the commands these people have given. This will be a slightly lengthy process compared to what we have seen. this is actually showing a very big process. Just give me 2 minutes. So get.docker.com was actually showing a much more simpler way for installing Docker, but now because for some reason the site is not opening up, so I had to go through some other process, a slightly bigger process, but doesn't matter. So friends, today what we are going to learn, in the last session of Docker, basically what we have seen is how we can start individual containers. That was what we were concentrating on. And in today's session, we will try to understand how containers can be linked with each other. Okay, why do we need to link containers? Because this is how you create the microservices architecture. Okay, we'll first start with a very basic scenario to make you understand how the linking of containers happen. Once you are clear with that, we will try to see some real-time examples of how a development environment can be created, how a testing environment can be created, etc., etc. There are various ways in which this linking of containers can be done. Okay, so why should we actually link containers? Because it's in your organization, it's not just one container that we use, it's a combination of multiple containers that we use. Each container can be working on a particular application. Okay, for example, I want to create a dev environment, and in my organization, just imagine that the developers are using WordPress. I hope all of you know what is WordPress. WordPress is a PHP based application which is used for creating websites. Even if you do not have much knowledge about HTML, etc., still we will be able to create excellent websites with WordPress. Okay, and here you see the WordPress always works in combination with MySQL, which means if you want to install WordPress, along with WordPress you have to install a MySQL database. Whatever activity the developer does on the WordPress database, that would be reflected into the whatever activity the developer does on the WordPress application, that will be reflected into the MySQL database. You can call this as a dev environment. In this way, different types of environments will try to create, but the basic criteria is I need to have a WordPress container linked with a MySQL container. How do you do the linking of multiple containers? To do linking of containers, one option is using something called as --link. This is one of the options which are available in our Docker run command. When you're using the Docker run, we can use the --link option, but the Docker documentation says that this link option is currently deprecated. What is the meaning of deprecated? It might not be available in the further, the further versions of Docker might or might not support. For example, just a few days back, someone actually told me that this get.docker.com is getting deprecated, which means we can't access it. But I did not take it seriously. Maybe that's the reason. Currently, we are not even able to open that get.docker.com. Tomorrow also, we just try it one more time so that we can come to the confirmation whether they have totally removed it. Similarly, the --link option is currently deprecated by Docker, which means further versions of Docker might or might not support. Okay, But for the sake of understanding, we'll first start with link and then we'll move into advanced concepts. The next one that we have to learn is something called as Docker Compose. This is very important. Docker Compose is used for creating the same multi-container architecture. If this is not there, the next one is we can use Docker networking. Okay, and other than this, I can also use simple Python programs for creating this architecture. So any one of them, of course, we'll be learning all these processes. You can use Link or Docker Compose or Docker Network or Python, or if you're good with shell scripting, even that can be used. Any scripting language can also do that very effectively. Okay, so we want to create a multi-container architecture. To demonstrate this, we'll start with a very easy example where I will take two BusyBox containers. This is my first BusyBox container and this is my second BusyBox container. You know what is BusyBox? It's a flavor of Linux, like your Red Hat Linux, CentOS, etc. I will call the first container as C1, second container as C2, and I want to create a link between both of them. If the link is established, I should be able to do a ping between the first container to the second container, right? Common sense. If the link is successfully established, we should be able to ping between both the containers. So this is what we are going to learn. Okay, using the hyphen link option, we'll first understand, then we'll move into Docker Compose and other concepts. Okay, so look at my screen. This is our AWS instance where Docker is currently installed. You can see that the version of Docker that is running is 18.09. Again, I'm saying the hyphen link option is a deprecated way. Some of the images might not support it. The upcoming latest versions of the images might even not support the link option. Doesn't matter. If it doesn't work, we have better alternatives like Docker Compose or Docker networking, etc. Okay, so since I installed Docker in my root account, I'll go into root and if I say Docker container ls, you see that currently we don't have even a single container, right? Now I want to start two BusyBox containers. Friends, tell me, what is the command for starting BusyBox containers? I can say Docker run. Always give the name of the image first. Okay, this is the way you construct the images, the containers. Docker run BusyBox. This is the command which will convert your BusyBox into a container. Once you define the actual command, now you decide what run command options you want to give. Remember, I gave you a list of all the run command options, right? So now you specify which option you want. I will say hyphen name. Let us call this first container as C1. Since this is a flavor of Linux, I want to go into the interactive terminal. We know that the option that we have to give is -it. IT stands for interactive terminal. So what this command is going to do, the Docker run command will check whether the BusyBox image is present on our local machine. If it is present, it will start it as a container. If it is not present, it will download from Docker Hub and then it will start it as a container. And the name of the container will be what? C1. C1 will be the name of the container. Okay, so let's execute. Brilliant. You see that that hash symbol that you see simply represents the prompt of your BusyBox container, which means we are in the C1 container. Now I want to come out of the C1 container. Generally, whenever we want to come out of a container, we are giving exit. But no, exit will actually take this container into exited status. I don't want to do that. I want this container to remain running in the background. Still, I want to come out of it. Okay. Actually, I mean, this is a slightly advanced concept. I don't want to discuss about this in today's session, but I'll just give you a basic understanding. Every Docker container, when you start a container, what it internally does is it will start a default process. What process? That depends on the container. But you need to keep in mind that whenever a container is started, internally that container is triggering a process. As long as that process is in running condition, that container is in running condition. If you close that process, that container goes into exited status. Okay, that's it. We'll go more in depth into this once I start Docker file. As of now, you understand that the BusyBox container, which is a flavor of Linux, when you start that container, what it does is it actually starts the shell as the default process. A Linux machine has a shell, right? That shell will be the default process. Now, if I hit exit over there, that shell will be closed, which means this container, the C1 container, goes into exited status. When the container has stopped, how can you ping to that container? Only when two containers are in running condition, I can check whether they are pinging or not, right? So I don't want to exit. I want to come out of the container without exit. For that, we have Control P, Control Q. Control P and Control Q, when you hit, that container goes into the background, but the control will come out of the container. Now I want to start one more container. Same busy box we want to start. Okay. And I'll give it a different name. I'll say hyphen name. Let's call it as C2 and hyphen ID because I want to open interactive terminal. But the criteria is the C2 container should be linked with the C1 container. That is what we want to do. To do that, in the run command options, there is an option called as link, hyphen link. You are linking it with which container? C1 container. So now Docker understands. Break down the command when you want to understand, friends. See this. Docker run, which image you are running? BusyBox. So it understands that BusyBox should start as a container. Then you are saying that you give this container a name called C2, open interactive terminal, and also link it with C1. But unfortunately, this link option always demands an alias. Alias in the sense some other name for the same container. You can give whatever name you want. I'll give the alias as C1 alias. Anything you can give, doesn't matter. Cat, rat, whatever you want. Finish. Now C2 container has started, but the criteria, the main thing is the C2 container has been linked with the C1 container. What is the proof? Check the ping connectivity. I'll simply say ping and then I'll say C1. We are in the C2 container. From the C2 container, we are checking whether the ping is possible or not. Absolutely. Do you see? You are getting the response from the C1 container. Finish. C1 and C2 have been linked with each other. I will simply say Control C for stopping. I hope everyone is understanding. It's as simple as that. We first created a BusyBox container. We named it C1. Then we started one more container C2, but we said that the C2 should be linked with C1. And this is some alias for the C1. With this, two containers have been created and successfully they have been linked with each other. Finish. This is how you do linking of containers using the hyphen link option, which is actually a outdated way of doing the things. Okay, but having the conceptual understanding of this will help you to understand the upcoming concepts more easily. That is why we are discussing this. What was the command to remain C1 in running state? Control P, Control Q. Simply say Control P. This is one thing, and then you hit Control Q. This will ensure that the container still remains in the background and you can come out of it. Can I ping from C2 to can we ping C2 from C1? Absolutely, Venkatesh, we can. But there's a small clause over here. I can't give the name of the container. I have to take the IP address of the container, then I'll be able to do it. Okay. I think I stopped that C2 container. Let me just check it. I mean, yes, C2 is still working. We have seen that when I'm in the C2 container, when you say ping to C1, it's working perfectly, right? What Venkatesh is asking is, can I go into C1 and ping to C2? You can, but not based on the name of the container. My name will not work. You have to wait. You have to wait to understand these concepts. Control C, I'll say Control P, Control Q, just come out of it. Identify the IP address of the C2 container. Docker inspect C2. When you do this, it shows that C2 container's IP address is 172.17.0.3. Once you identify this IP address, then I will go into C1 container. Any container which is running in the background, you want to go into it. The command is docker attach. Docker attach C1. Once I go into the C1 container, if I say ping, and if I give the IP address of the C2 container, you see that it pings. Whereas if I directly try to give ping, and if I say C2, it does not ping. Okay, what is the reason? We'll try to understand. This is one advantage of the link option. C1 container has been linked to the C2 container. When you started the C2 container, you explicitly said that this C2 container should be linked with C1. So as long as the control is in the C2 container, you will see that the C2 will ping to C1 based on the IP address or the name of the container. But once you come out of that and you go into some other container, you can still ping, but not based on the name. You have to use the IP address. Okay, just keep this in mind. Fine. This is a very simple example. I'll exit from this container. I'll also remove all the containers. What is the command for deleting all the running and stopped containers? I hope you people remember these commands. ps-aq. So this is going to stop all the containers. In our case, only 2 containers, C1 and C2, they are deleted. Now, one by one, let us take some examples of how, probably these are the examples that you can actually talk, saying that you have created this kind of environment, but not via link option. You have to say that these things you have created via Docker Compose, but we'll slowly go into that. As I told you a few minutes earlier, I want to create a WordPress container linked with a MySQL container. Okay, this is the environment which is required for the development team so that they can create their web application via WordPress. In the background, it should have MySQL in running condition. I want to create this entire setup, install WordPress, and see whether that's it, whether the necessary environment for developer has been created or not. Okay, how WordPress website is created, that's not our headache. We are not WordPress developers. We don't know PHP and all that. Leave it. We are just trying to understand whether the necessary environment we are able to create or not. Okay, I think I'm making myself clear. So let's start the containers. I would like to start MySQL first. So I'll say docker run MySQL. Explicitly, I want to start MySQL 5 version. Okay, if 5 is not working, we can go with some other version. Hyphen name, let's call it as mydb. -d. -d, why do you give? When you want your container to run in the background, I don't want the logs to be generated on my screen. D stands for detached mode. It will ensure that the entire container runs in the background. -e. E is for environment variable. So you can say MySQL _root _ password, and I will give whatever password I want. Okay. So friends, again, always break down the command docker run MySQL 5. So it understands that we are going to start MySQL as a container. The name of the container should be mydb. We would want to run this in detached mode, and we have already discussed in the last session that this MySQL mandatorily requires an environment variable. What is that? MySQL root password. So with this, see what it is saying. It says unable to find the image locally, so it's trying to download, and then it will start as a container. Okay, finish. MySQL has started and it's running as a container. Once MySQL starts, I want to start WordPress as a container now. So always create the basic command first, docker run WordPress. Now you give the arguments. What are the arguments? -name. Let's call it as my WordPress. This is the container name. -d, detached mode. -p. Why p? Because WordPress is an application which you access from a browser. It's a web-based application. So I have to perform port mapping, right? So what is the internal port of WordPress? It's 80. You link it with whichever number you want. I will link it with 9090. How do I know that the WordPress internal port number is 80? We don't need to know it. Go to hub.docker.com, the cloud site of Docker. And there you just search for WordPress. Just search for WordPress. Please observe. This is the official image of WordPress. Now, they will give you detailed documentation about what is WordPress, how it works. Now, if you have patience and time, maybe you can go through this. If you don't have, just take it, just leave it. Please see, docker run WordPress. What is the port mapping they are doing? 80 is the internal port. External port is our choice. I can give anything. These people are giving 8080. I have given 9090. But the container port is 80, which you can't modify. And that is what I have done. And I want to link this WordPress. Sunny, what is your question? we also need to make sure which version of which container is compatible with another container before linking them. Absolutely, Sunny. Absolutely. And we don't know. We don't know which version will be really compatible with which version. So it's just like you have to try it. I earlier tried with some versions of MySQL. It's not working. So I went to an older version of MySQL. And recently someone was saying that even this older version, MySQL 5, was also giving a problem. So we have to try now. In case that 5 doesn't work, I'll alternatively check some other versions. Either the WordPress version, you have to go to an older version. Some kind of compatibility issues always happen. We need to check it. Fine. So I want to link this WordPress container with the MySQL. So I will use the same -- link option. What is the name of the MySQL container we started? MyDB. And you give an alias. Shall we give the alias as MySQL? Whatever we want, right? Finish. With this, WordPress is starting and it is getting linked with a MySQL database. If it is really linked, a developer should be able to install WordPress within the container and he should be able to create his WordPress website. Let's check it. This is the machine where all of our Docker containers are running. So I just go to that machine. And what was the port number we have given? 9090. This should take me to the WordPress installation page. Yes, absolutely. WordPress as it is running in a container. Okay. So now you click on continue. It's asking me to enter a site title. I'll give the site title as IntelliQID. Okay. I'll give the username as admin. Password I'll give as admin. It says it's a weak password. It's okay. And then it's asking my email ID. So I'll just give my organization email ID. Okay, and search engine visibility. It says discourage search engines from indexing this website. If I click on it, you know what that means? It means that search engines like Google or Yahoo or Bing, they will not be able to identify this website. But I have a question. Why do you think someone would want to create a application which they don't want search engines to identify? Okay, I'll click on install WordPress. Click on install WordPress, finish. Click on login. Our activity is over. As a DevOps engineer, your activity and my activity is over. Now a developer will come and that fellow will create a website. If you know WordPress, maybe you can create a sample website. It's not difficult. I mean, you don't need much knowledge. You can just, majority of the activities are drag and drop. If you spend half an hour on this website trying to customize, it will allow you to do a lot of activities where, a sample website can be created very easily. But because this is a developer's work, we don't need to break our head on it. But I hope everyone is understanding. This WordPress container we are able to access only because internally it is linked with the MySQL database. Now, I just want, if you have time, I just want you to open YouTube and check how WordPress can be installed on your Windows machine or Linux machine. Doesn't matter. What is the complete process of installing WordPress? You will see that they'll show you a process which takes at least 1 hour time. Big process where they first create MySQL, they'll again put some application server. They of course WordPress internally itself has an application server. They install this WordPress, they link with that MySQL connection strings, etc., which takes 45 minutes to 1 hour. Whereas now with Docker containers, you are able to just start 2 simple containers, link both of them, and you see a complete development environment where a developer can start creating his application has been created. I hope everyone is understanding what we are trying to do. Okay. No, Sunny. WordPress container will run individually. There's no question about it. But you will not be able to do these activities like creating an account, logging into that account, and trying to create a website. Because whatever activities you are doing, when you are trying to, we initially created an account, right? All that data would be stored only in the MySQL database. That is not possible if you don't link it with a MySQL database. Only simply running as a WordPress container, that will happen. But you want to access it from browser and do so many activities that we are doing, that you can't do. Okay, so a complete environment we have created, basically. That's what I'm trying to show you. Okay, so friends, this is just one simple example of how development environment can be created. Okay, I'll show you another example which some of you might be already knowing. This is how I can create a entire Jenkins related setup. Generally, when Jenkins people work, what they do is a Jenkins admin creates a server where they will install Jenkins. And then Jenkins is a tool using which they can perform CI/CD. Now, I can't explain what is CI/CD in these sessions, but if you have time, just go through Google and try to find it out, because we are trying to create the necessary setup with Docker. Imagine that this is my QA server where Tomcat is running. This is my prod server where Tomcat is running. Once the Jenkins setup is created, what what a developer generally does is, what a Jenkins admin generally does is, with the help of Jenkins, he'll download some code, he'll convert that code into an artifact or a setup file, and he'll deploy that into the testing environment. Here, Jenkins will run some automation programs, check whether it is okay or not. If it is okay, that artifact will be deployed into the production environment. That flow we generally call as CI/CD. Now, whether you know CI/CD or not, just leave it, doesn't matter. What we are trying to concentrate over here is, through Jenkins, I want to create this setup. The regular setup, if you want to create on Linux servers, you want to create 3 Linux servers where for installing Jenkins, the precondition is you need to install Java and a few other softwares. This complete setup you will see will take half an hour, 45 minutes. I want to just create it in the format of Docker containers in just a matter of seconds. Okay. So that a Jenkins admin will be able to do continuous integration. Okay, we are just trying to create the necessary environment which a Jenkins admin can do for doing continuous integration. If you know continuous integration, you will be able to practice it directly on the Jenkins containers. If you don't know, just leave it, because as a Docker engineer, you are trying to create the setup. That's it. Okay, so I think it's timed out. So just a second. It's taking so much time. Fine. So friends, let's go into the root account, and please let's just watch. I'll delete all the containers. You know why I constantly keep on deleting the containers? Because we faced this problem in the last session also. Insufficient disk space issues do come up very quickly because we have only 1 GB RAM on these AWS instances and very limited amount of hard disk. So friends, I want to start a Jenkins container. What is the command? Docker run Jenkins. Finish. Docker run Jenkins is the name of the image which will start as a container. Now you give it a name, -- name. I'll call this as dev server, -d because I want to run in detached mode, -p. The internal port of Jenkins is 8080. I would like to link this with any number. I will say link it with 5050. So with this command, Docker will check whether the Jenkins image is present on our machine. If it is present, start it as a container. If it's not present, download it and then start it as a container. It's done. Jenkins container is running. What is the proof that Jenkins container is running? I should be able to access the home page of my Jenkins to the same browser, but the port number that we have given was what? 5050. It should take me to the home page of Jenkins. Yes, you see, the Jenkins page is loading up, which means compared to the regular installation of Jenkins, we are able to start the same Jenkins as a container in just seconds, a few seconds, right? Similarly, now we'll start a Tomcat, which is supposed to work as a QA server, and we'll link it with the Jenkins container. So the command is, precondition is Java need to be installed. Prem, when you say container, what is the meaning of the container? Container contains everything that is necessary for that Jenkins setup. For example, Jenkins requires, if Jenkins has to be installed, it requires Java. So this container will have Java and also Jenkins. We don't need to install it. Any additional software you want, you have to install it. For example, Git and Maven will not be present. Maybe I have to go and install. But the precondition for Jenkins to come into running condition, Java should be present. Then only Jenkins comes into running condition. So that will be present in the image itself. Docker run Tomcat. So this is going to start Tomcat as a container. Now let's give it a name. I'll give the name as QA server, and then I will say -p. The internal port of Tomcat is also 8080, but I want to link it with 6060 on the host machine. And more importantly, this Tomcat container should be linked with the Jenkins container that we started just a few minutes back. -link dev server alias. You give whatever alias you want. I'll give the alias as Jenkins. So Tomcat is getting downloaded, and then it will start as a container. And it's linked with the, oh, I did not give -d option. Oh, you see, when you don't give -d, it keeps on generating these logs. So let me just close that, delete that container, docker rm-f. What was the name of the container? QA server. Okay, once it is deleted, we'll run the same docker command, but I will also give -d option. Now Tomcat is running in the background and it's linked with the Jenkins container. Can we link two different containers if they are not linked? Sunny, I mean, it's a good question, but I think it's slightly advanced. I did not want to talk about this at this point of time. Earlier, Venkatesh was also asking a similar question. I just intentionally wanted to avoid that concept. The truth is, even if you don't give that -link option, containers will be linked with each other. Okay, so the next question you will ask is, then why are you giving this -link option? That's why we said that this is a deprecated way. Once you understand Docker networking, you will see that containers are internally handled in an entirely different way. Whatever processes I am showing you in today's session, you try all these same processes without the link option. You'll see still they'll work. Okay, but and it will create unnecessary confusion if I talk about all those things now. So let's go in a step-by-step process. As of now, please imagine that linking of containers is done only via -link option. Later you will understand why this link is not necessary. So friends, I want to start another container, but this time I would like to call this container not as QA server, but I would want to call it as prod server. Okay, and I want to map a different port number on my host machine, 7070. Please look at the command docker run. The image name is Tomcat. You are giving this time the container name as prod server. You are saying that the host machine 7070 should be linked with 8080, and of course even this container should be linked with the dev server container, which is nothing but the Jenkins. So what we have done is we started two Tomcat containers and linked it with one Jenkins container. If you give the command docker container ls, you can see that yes, we have a Jenkins container which was running since the last 4 minutes. We have a Tomcat container with a name called QA server which is running since the last 1 minute, and the latest Tomcat which is prod server running since the last 9 seconds. And in fact, which container is linked with which container, that information also you can see by using docker inspect. For example, docker inspect QA server. When you do that, in this huge output, search for an option called links. Anywhere you see links? I missed it. Somewhere it should show that it is linked with some container. Yeah, you see? In the JSON file format output, in the link section, it shows that it is linked with dev server. This is the alias name. Okay, finish. So the complete environment of CI/CD has been created, and of course, you want to see the home page of the QA server. You give the port number. Which port number I have given? 6060. You see, similarly, the next one was prod server 7070. The same Tomcat opens up there also. So you have created the complete environment which a Jenkins admin can do, can use for installing his CI/CD. Now the next concept that I'm trying to show you was an interview question which they asked in Honeywell. Okay, probably if you have knowledge of Jenkins, you will understand what I'm talking about in detail. If you don't know, just follow the notes that I'm giving you, and if they ask such a question, you can actually talk about that. Okay, I mean, because if you are not related to Jenkins, you will not really understand how internally these applications are going to work. So if you can clearly explain the concept of how the linking happens, that would be generally sufficient. Okay, a Jenkins admin would probably know what I'm talking about, but in Jenkins, there is a concept called as master slave. What is this master slave? This is a feature of Jenkins using which the main machine where Jenkins is installed is called as the master machine. If this master machine is having a lot of Jenkins jobs and running these many jobs becomes very difficult, then what Jenkins does is it will create an additional Linux server which will work as a slave machine. To create this slave machine is nothing but any regular Linux machine where you download a jar file called as slave.jar. The slave.jar will be present initially on the master machine. You download it into the slave machine. Once it is downloaded, this will start accepting the jobs coming from the master machine. Now I can create any number of slaves in this way. Maybe I'll call this as slave 2, provided you download the slave.jar. Okay, the slave.jar will be downloaded from the master. Once this environment is created, Jenkins will be able to run the jobs on the slave machines also. The question they asked in Honeywell was, how do you create this master slave setup? Generally, Jenkins admin would create this master slave setup on his regular Linux servers. Now they asked the question, how do you create this setup on Docker containers? So let's try to handle that scenario. I'll delete all the running containers. Okay, now once that is done, let's start a Jenkins container. The same drama, docker run Jenkins, and you give it a name, hyphen name. For the sake of understanding, we'll call it as master. -D for detached mode, -P. You people know that 8080 is the Jenkins port. If you don't know, just go to hub.docker.com and check it. Or else, if this port mapping and all this is creating conflicts or issues, just give capital P. Capital P will do automatic port mapping. So Jenkins has started as a container. If you say docker container ls, you will see that Jenkins is running. The internal port 8080 is linked with 32769. So I should be able to access the Jenkins homepage via the same public IP, but the port number is 32769. It should take me to the Jenkins homepage. Okay, the main installation page of Jenkins. Okay, fine, that's done. Now the requirement was you create a slave. In the sense, I can just take a Ubuntu container, and that Ubuntu container can be treated as a slave, right? So the command is docker run Ubuntu, and now I will say hyphen name. Let's call it as slave -IT for opening interactive terminal, and this should be linked with the master. So I will use -link. You are linking it with which container? Master alias I'll give as Jenkins. Finish. So Ubuntu container is starting, and this Ubuntu container is linked with the Jenkins container. Simply download the slave.jar. wget command will help you to do that. Slave is present where? It's present in the master machine. Master is running on port number 8080, and it's present at a location. This is the location where the slave.jar will be present. Okay, this is not Docker command. This is just a Jenkins related portion where the slave.jar can be downloaded. Unfortunately, it says that wget is not available in the container, so we'll install wget. Install wget apt-get install. Once wget is installed, I give the same wget command again. And if you do ls, do you see? Wow, server error.
It's a slave.jar. You given salve.jar.
Oh, sorry. Yeah, fine, brilliant. Thanks. The name of the file is slave.jar. Brilliant. Now if I do ls, you can see that the slave.jar file has been downloaded, and of course the master slave setup has been created. I hope you are understanding what we are trying to do. Okay, so any kind of environments you want to create, Docker actually simplifies that to a very great extent. Fine. Let me delete these
Hello,
containers.
Sai.
Yeah, tell me.
Yeah, one question regarding master slave. Previously, what we saw in the Docker, we create two different environments. Here we are having only one environment where we are
Yeah,
having two containers.
true.
So how internally it is working?
No, what is the difference? Why do you think that you require two environments? What is the problem if everything is running on the same environment? Earlier, probably Jenkins admins might be creating that on separate Linux servers. Here you are creating it on separate Linux containers. A container is also behaving like a additional Linux server itself, Prem. The behavior of a container and a
Okay.
Linux server both are same.
Okay.
Particularly if you are just going with a virtual machine or something like that, you go with a regular installation where you do it. Now in the place of a virtual machine, you are just using a container. Behavior is just the same, Prem. There is no difference.
Okay.
Okay, friends, this is we are just trying to see a lot of examples only because you can actually in your interviews you can say that using Docker we have created these kind of environments. Okay, one more example I'll show you. There is a very famous architecture which is called as the LAMP architecture. I'm sure most of you know about this. What is LAMP? LAMP is an architecture which works entirely on open source technologies where they say that the operating system should be a Linux operating system, which is a free operating system, right? The application development should happen via a technology called as PHP. The backend database should be running on MySQL, and the application server should be running on Apache Tomcat. This is a development environment where a lot of organizations create the application via PHP. Their database is MySQL, and Apache Tomcat will be running. And of course, everything is running on a Linux operating system. This is called as the LAMP architecture, which is generally how they do is they take a Linux machine. On that Linux machine, they install PHP, they install MySQL, they install Tomcat, and of course, all containers should be linked with all containers. Okay, so they create this kind of link. Now, this complete LAMP architecture I want to create via Docker containers. Anyhow, we are sitting on a Linux machine, so I don't require a Linux container. Already we are sitting on a Linux machine, right? So no need to go with a Linux container. All I require is a PHP container linked with a MySQL container and a Tomcat container. Link between all three containers should be established. Earlier, what we did, we took a Jenkins container, we linked it with one Tomcat container, one more Tomcat. We did not create a link in this way. This we called as the QA server, this we called as the prod server, but link did not establish here. But now I'm saying I want link in all three containers. Okay, so let's see how it works. Please watch. Docker run. I would like to start MySQL, and then I'll say -- name mydb and -d for detached mode, -e MySQL _root password, and I will give whatever password I want. This is going to start MySQL as a container. Okay, once MySQL comes into running condition, we want to start Tomcat. So the command is docker run Tomcat, and then we'll say -- name. Let's give the name as Apache -p Tomcat runs on port number 8080. I will link it with any number. Okay, and this Tomcat container should be linked with the MySQL container. Link. What is the name of the container? MyDB alias. I'll give the alias as MySQL. So this is going to start Tomcat as a container and link it with the MySQL container. I want you people to go through today's concepts, because tomorrow Docker Compose, you will see that is entirely based on these concepts. The same scenario that I'm trying to show you today, I will try to implement on Docker Compose. Oh, you know, again the same drama. We did not give the -d option. Let's delete that container. Docker rm-f. Okay, now the same command for starting Tomcat, but I want to run this in detached mode so that all that nonsense don't come on my screen. Brilliant. So MySQL container, and it's linked with Tomcat. Now I want to start PHP. Docker run PHP, but let's check what is the exact name of this PHP. Sometimes you have some versions or something else. So go to the hub.docker.com and there you search for PHP. As always, I'll go with the official image. And in this official image, directly you can look at the commands they are using. This is Docker build, which means using some Docker file they are trying to create. So there is an image called as Docker PHP 7.2 CLI. Different flavors are there. So let me just go a little down. Yes, I want to run as an arbitrary user, which means I don't want to go with see, these are the different image names that are available. PHP version -CLI, PHP version -Apache. Maybe you can use any one of them. So I'll use PHP 7.2 Apache. That's the image name. So Docker run PHP. Okay, and now you give it some name. I'll say -name PHP -d for detached mode -link. It should be linked with what? MyDB, alias is MySQL. It should also be linked with the Apache Tomcat. So again you say -link. It should be linked with a container called as Apache, and for this Apache the alias I'll give as Tomcat. So you want one container to be linked with multiple containers, you can just use this -link option multiple times. Okay, so look at the command. Docker run, which image we are trying to run? PHP 7.2. So that will start as a container. Once it starts as a container, we are saying that we should give it a name PHP, and then it should run in detached mode, and of course it should be linked with the MySQL container and also with the Apache container. Apache is nothing but a Tomcat. Finish. All the three containers have been created. If you give the command docker container ls, people who know PHP will be able to create a application using this LAMP architecture. Okay, so this is how any kind of scenarios you can take and you can convert those into containers. Now I will actually just talk about one scenario that I have implemented in my previous organization. We implemented that on a very large scale, where probably 800 containers were linked with each other. I will actually try to show you the same scenario, but not 800. We just create 3-4 containers, but you'll understand the flow. What it is, I'll try to explain. See, the client for which I was actually working, they said that their application has to be tested on multiple browser and OS combinations. Okay, listen to the use case carefully. And we had an automation testing team who created the necessary programs using Selenium. Okay, they created these programs, and these programs are capable of testing that application on different browser and OS combinations. You know what it means? For example, Mozilla Firefox, they wanted to test on 25 to 54, which means how many versions totally? 30. Similarly, Google Chrome, they had some count. Similarly, on IE, they wanted to test on 8, 9, 10, 11, etc. They wanted to test on Edge. Like this, these browsers, they wanted to test. All these, they wanted to do on Windows 7. So on one machine, for one browser, you can have only one version installed at one point of time. But these Selenium programs are created in such a way that if the necessary infrastructure is available, it will parallelly launch all those browsers on those OS and it will do the testing rather than wasting time. But to create this infrastructure, we require minimum 30-40 machines, because one machine will have only Mozilla Firefox 25. Another machine will have Mozilla Firefox 26, 27, like that. So many machines with Windows 7. Again, we wanted to do the same testing on 8, 8.1, Windows 10. That too, in each of these operating systems, you have different flavors like Standard Edition, you have Home Edition, Basic Edition, Enterprise Edition, Professional Edition. On all these things, they wanted to test. Similarly, different browser and OS combinations, they wanted to test on Linux also. When you say Linux, it can be so many flavors: CentOS, Red Hat Linux, it can be Ubuntu, so many different flavors with all these browser and OS combinations. Can you imagine how many permutations and combinations it will create? We estimated that we required almost 800 plus browser and OS combinations. 800 plus browser and operating system combinations. Now, it's the responsibility of the infrastructure team to set up these 800 machines, either as VMs, virtual machines is okay, or else physical machines, anything is okay. The tester is not concerned with all that. That fellow has simply created the necessary Selenium program. When it is executed, it will parallelly execute on all these machines. But creating an infrastructure of 800 VMs or whatever it is was a very big challenge. It was very difficult. So at that time, I mean, initially, we did not create VMs. We were, our organization was depending on a cloud service provider called as Sauce Labs. Just go into Google and search for Sauce Labs, you'll know what it is. What the Sauce Labs community does is, you just tell them which browser and OS you want, and on their cloud, in a matter of seconds, they'll create all those machines, and your Selenium program will happily do the testing on those machines. In a matter of seconds, they'll create all those VMs. But the problem is, Sauce Labs is not a free cloud. It's extremely expensive depending on how many hours your automation programs are running. For how many hours these machines are running, 800 machines, you have to pay them very heavily. So at that point of time, we did POC on Docker, checked whether Docker could be used in its place, and out of this requirement of 800 what they were asking, almost 600 plus OS and browser combinations we were able to create via Docker containers. For the remaining 200, they depended on Sauce Labs, but almost 600 plus we were able to run successfully as containers and do the complete automation testing. Of course, initially, because at that time we were doing POC just to create this setup, how to understand, do R&D and do the complete setup, we took almost 2 months of time. But later, once we understood the pros and cons and how this complete setup can be created, now we can just create it in a matter of few minutes with one single Docker file. But initially, we did not know whether it works or not, so much time we had to take. So tomorrow I'll actually show you how that environment can be created. You will see that anything, it can be development, testing, whatever you want, all those things can be created with Docker. Now, someone was asking me, when will we start Kubernetes? See, this is not just a Kubernetes course. You can't learn Kubernetes without having knowledge of Docker. Until and unless you know all these concepts. I mean, if there is someone who already knows all these things, what I'm talking about, maybe you might feel it is bored. You might be waiting only for Swarm or Kubernetes. But when you say Kubernetes and Docker are just one thing. You have to learn Docker. You have to learn Docker, Swarm, Kubernetes. That is the flow in which things happen. Directly, if I launch Kubernetes over here and start doing container orchestration, how containers run in a production environment, how load balancing is happening, and all those things I'll show, you won't understand anything of those things until you are clear with this. So you should be clear with how initially Docker is used for dev environment, testing environment, how Docker Compose works, how you create your own customized images, how you work on Docker registries, Docker networking. Once all these concepts are done, then you will really appreciate what is happening when we start Docker Swarm and Kubernetes. Okay, so let's take time. Please spend some time trying to practice all these things. We'll send the notes of whatever has been covered today. So please go through the notes, and of course go through the video also. If there is some concept which maybe you feel I'm moving fast or something, just go through the video one more time, and detailed step-by-step notes of whatever has been done in today's session, I'll send it to you. Just follow the notes as it is. You will be able to create the necessary environments. Okay, so no, you can't do that, Sunny. -D option, you can't use it in any of the Linux based kernels, because you are actually issuing a contradictory statement. You are saying that I want to open IT. IT simply means interactive terminal. On one hand, you are saying that I want to open the interactive terminal, and on the other hand, you are saying that I want to run in the detached mode. That's not possible. You can't do that. You don't give -IT. You want to give only -D. That will work. It will launch the container in detached mode, but you won't go into the shell of that container. Okay, that can be done, but don't do both, because IT is telling you open that container in the front end so that I can do something. D is saying don't open it in the front end. Both are different. So never use -D and IT in the same command. Two separate commands there. Okay, so fine friends, thanks a lot. We'll stop the session. Just check, maybe I don't know what happened today with that get.docker.com. If that's not there, it'll be a big problem. We have to follow so many steps for installing that Docker. See, it's not working, I think. Fine. So we'll stop the class. Maybe tomorrow we'll go with the other concepts. Okay. So thank you all of you. Bye.
Thank you.